Electromagnetic spectrum. Waves that surround us all the time are electromagnetic waves. Electromagnetic waves can travel through your body, they enable you to see, they can make your skin feel warm, and are found when you watch television, talk on the phone, or use a microwave. Unlike water and sound, electromagnetic waves do not require matter to transfer energy. They are made by vibrating electric charges and can travel through space where matter is not present. Instead of transferring energy from particle to particle, electromagnetic waves travel by transferring energy between vibrating electric and magnetic fields. Just like sound waves are produced when something vibrates, electromagnetic waves are also produced when electric charges vibrate. All electromagnetic waves travel at about 300,000 kilometers per second in the vacuum of space. Because light is an electromagnetic wave, the speed of electromagnetic waves in space is usually called the speed of light. And it's nature's speed limit, actually. This is why we say nothing travels than the speed of light. Now, the speed of electromagnetic waves also depend on the material they travel through. Electromagnetic waves usually travel the slowest in solids and the fastest in gases. They can also have a wide variety of frequencies. They might vibrate once each second or trillions of times each second. The entire range of electromagnetic wave frequency is known as the electromagnetic spectrum, shown here. Various portions of the electromagnetic spectrum interact with matter differently. As a result, they are given different names, and the electromagnetic waves that humans can detect with their eyes is called visible light, and is a very small portion of the entire electromagnetic spectrum. The other portions of the electromagnetic spectrum include radio waves, microwaves, infrared waves, ultraviolet waves, X-rays, and gamma rays. Various devices have been developed to detect other frequencies. For example, the antenna on your radio detects radio waves. Radio waves are moving everywhere you look. Some radio waves carry an audio signal, like from a radio station to a radio. However, you can't hear those radio waves. Radio waves are actually low-frequency electromagnetic waves, and those that have a wavelength of less than 30 centimeters are called microwaves. And the microwaves that have wavelengths between 1 to 20 centimeters are widely used for communication, such as cell phones and satellites. But you are probably most familiar with microwaves that are found in the appliance in your kitchen, the actual microwave. Now, microwaves in your kitchen work by interacting with water molecules in your food. The vibrating electric field caused by a microwave often causes water molecules in food to rotate back and forth billions of times each second, causing friction between the water molecules. This generates thermal energy or heat, and this is the heat that is going to cause your food to cook. Now, another use for radio waves is to find position and movements of objects by a method called radar. Radar stands for radio, detecting, and ranging. Law enforcement officers use radar to measure how fast vehicles are moving, and it's also used to track movement of aircraft, watercraft, and even spacecraft. Infrared waves are a type of electromagnetic wave with wavelengths between 1 millimeter to about 7/50 billionths of a meter. When you sit next to a bonfire and you feel the warmth of the fire, you are actually feeling thermal energy that is transmitted to you by infrared waves. You also use infrared waves every day in remote controls. And actually, in fact, every object emits infrared waves. Hotter objects emit more infrared waves than cooler waves. Infrared detectors can forward images of objects from the infrared radiation they emit. You might have seen this on forensic shows or spy shows when they use infrared vision and can detect a person by their heat signature. Now, visible light is the range of electromagnetic waves that you can detect with your eyes. Light differs from radio waves and infrared waves only by its frequency and wavelength. Your eyes contain substances that react differently to various wavelengths of visible light, so you can see different colors. These colors range from short wavelength blue to long wavelength red. And if all the colors are present, you actually see the light as white. Ultraviolet waves are electromagnetic waves with wavelengths from about 400 billionths to 10 billionths of a meter. They are energetic enough to enter your skin cell, but overexposure to ultraviolet rays can cause skin damage and cancer. Most of the ultraviolet radiation that reaches Earth's surface are longer wavelengths called UV rays. And this is why we use a UV blocker or sunscreen to prevent sunburns that may cause skin damage, right? However, some ultraviolet light striking our skin is healthy for us because it enables our body to make vitamin D, which is needed for healthy bones and teeth. Another useful property of ultraviolet waves is also their ability to kill bacteria on objects such as food or medical supplies. The electromagnetic waves with the shortest wavelength and highest frequencies are X-rays and gamma rays. Doctors and dentists use low doses of X-rays to form images of internal organs, bones, and teeth, and are used in airport screening devices. And gamma rays can penetrate through several centimeters of lead and are used to do radiation therapy, which kills diseases in human bodies. When handling gamma rays in a lab, if not done properly, I've heard it also results in a person turning into an Incredible Hulk. Just kidding, just seeing if you're paying attention. Now it's time to show what you know.